Okay, we left off with this impossible diagram. Java only allows each class to have one and only one parent. But it seems like multiple inheritance is a really desirable trait here. So how are we going to solve that? The idea of multiple inheritance is that a class can inherit from multiple ancestors. But Java doesn't allow that. There are other programming languages like C++ that do allow for that, and it's the complexity that gets added into a C++ inheritance hierarchy that prompted Bill Joyce, the creator of the Java language, to not allow it for Java. So you can't have multiple inheritance for classes, but you can have multiple inheritance for interfaces. So an interface is a new keyword, and just to make life interesting, it used to have a very clear definition, and with Java 8, Oracle, who now owns the Java language, muddied the waters a bit. Let's go with the base understanding of what an interface is. Let's say, instead of actor being a class, actor defines an interface. And an interface is a contract. If a class says it will implement an interface, that means that every method that is described by its signature must be implemented as a non-abstract method in the class. So, for instance, if we say that the actor interface says that there has to be an act method and we have to have a method which returns a Boolean for is this object active in the simulation. That means that any class that implements actor will have an act method which returns void and will have an isActive method which returns Boolean. So, ways that interfaces get wired in is that we use the implements keyword. Fox extends animal, that's inheritance, but it implements drawable. So this is the contract of what methods need to be included. Public class hunter implements actor and also implements drawable. This is the multiple inheritance version where you can have more than one interface being implemented. Okay, that's cool, I guess. It's actually really, really useful. One of the things where this becomes exceptionally useful is that just like classes, interfaces define a type. So you can have a variable of type actor. You can have a variable of type drawable. And then any object that implements that interface can also be stored and make use of polymorphism inside of that variable. Pause to think about that. I mean, we're getting into some heavy-duty expansion of what inheritance can do and what object-oriented programming can do. At its most basic, for interfaces, it will give you a list of method names, and then you need to implement them and give them their bodies inside of the implementing class. That's really what interfaces were meant to do from the start of Java, from Java 1 up through Java 7. Now, things get a little bit muddier, but this piece is kind of the base for right now. When you create an interface, it's public interface rather than public class, and then you give them a name. Interfaces, because they are not classes, they don't have constructors. They're just agreements on what other classes are going to have to implement. All the methods have to be public because if it's an interface, there's no reason for there to be something private there. If there are fields, they are public, static, and final. So basically, they're available to everyone, and they are immutable. So it's a way to set up constants. As such, the keywords can be omitted, but it's sometimes useful to have them just so you know what they are. Because interfaces are by definition, or at least up until this point, were abstract, you don't have to use the abstract keyword either. So make sure you check out the sample interfaces inside of the chapter's projects as well. Now, here's sort of the weird part of interfaces. This started with Java 8. There are certain use cases where you want something to implement an interface, and you want every object that implements that interface to share a common implementation. And so you can have a default method body. And I read through the use cases on the Oracle website, and I can understand why they exist, but they muddy up the linguistic purity of what interfaces were meant to do. Know that you will see code that has an interface and might have a default or a static method inside of them, and it means that it has to work with Java 8 or later, and you will inherit code that will have this. Just make sure that it's well documented why that exists as an interface instead of as an abstract method or as a method within an abstract class. The reason why you want to be aware of this is because interfaces define what code will be implemented historically. If they then implement code and you can have multiple interfaces, it is conceivable that two different interfaces will implement a method with the same name. That will complicate multiple inheritance. Now, it sounds like an edge case. An edge case is something that wouldn't happen too frequently. But it's the edge cases that create problems for every program. So the default methods were introduced in Java 8. And if you have two classes that have the same signature, they must override the method. So it's the name of the interface .super.method name is the way that you end up doing the override. That's just a little bit of trivia. For what we're going to do, we are not going to use default methods. You're not going to run into this. Just know that it could happen. The way I do want you to think about interfaces is this. Interfaces are contracts. Interfaces are specifications. Interfaces give us a way to separate out what the object does from how it actually does it. What the object does is specified by the names of the methods and the parameter types and the return types. But how it does it internally, well, that's up to the implementing class. The nice thing then is that if you have a clearly defined interface, you can plug and play different implementing classes into that interface variable as needed. So, for instance, we've been working with array lists, but there's another type of list called a linked list. Both array list and linked list implement the list interface. That means that you could try your code with an array list, and then you could instead have a variable that is a linked list and see what the impact is there. The data type for the holding variable would be list, but the implementation would either be a dynamically type, the dynamic type would be array list, or the dynamic type would be linked list. I know that's a lot to think about. Let's take a few moments. When we come back, we're just going to look at a special feature of a particular type of class that's inside of the Java specification, and then we'll wrap up Chapter 12.